Well, welcome to my kitchen. Here's where I do all my favorite chemistry, brewing my coffee, making my meals. Today what we're going to do is look at the experiment for this project. What is the effect of cooking on the nutritional value of food? So the food that we're working with is apple juice. And what I want to show you is how I'm going to cook the apple juice here on my stove to different temperatures or at the same temperature for different amounts of time. And then I'll titrate the samples of apple juice to find out how much vitamin C they have compared to how much they had before they were cooked. Let me show you how I'm going to use the stove to do that. Okay, so here on my stove I have a pot of water, and in the pot of water I have a beaker, and I can put test tubes into the beaker to heat them up for different amounts of time or at different temperatures. I have a thermometer here going into the beaker of hot water so I know what the temperature is. Here are the different cooking treatments that I'm going to use. So I'm going to cook some of the apple juice at 100 degrees for these different amounts of time. And so what I'll do is I'll put the test tubes into the hot water for half a minute or 1 minute or 2 minutes or so on at this temperature, and then I'll take them out and I'll titrate them to find out how much vitamin C they have. I can also do the same thing for the same amount of time, 5 minutes. I can put tubes into the hot water at different temperatures. So I'll make the water to be 30 degrees Celsius, and then I'll put in a tube for 5 minutes. I'll make the water to be 40 degrees Celsius, put the tube in for 5 minutes, and so on. So the same amount of time, but increasing temperature. And all of these I'm going to compare to a sample that isn't cooked. It will be heated for 0 minutes at 20 degrees Celsius, which is room temperature, so it's not cooked. Everything else is compared to this one. Let me show you how I'm making the samples. Okay, so here's the sample that's not being cooked. It's 10 milliliters. I used a pipette to fill all of my samples with 10 milliliters of the apple juice. And I made a separate tube for each one of the tubes that are going to be put into the boiling hot water, 100 degrees, for each increasing amount of time. And also tubes that have 10 milliliters of apple juice in them that I'm going to put in for 5 minutes at increasing temperatures. So then after these are all done cooking, I'll have a cup for each one, and I'll pour each one into a cup, and then I'll titrate it the way that I demonstrated in my introduction video. I'll go through those titration steps again when I show you the results of the experiment. Here's another set of samples that I'm preparing. This is probably the most important part of the experiment, establishing the standard curve. Since we don't know how much vitamin C there is in the apple juice, and since we don't know how much of the titrant it takes to change the color of any particular amount of vitamin C, what we need to do is make a standard using known amounts of vitamin C. So I took some vitamin C tablets and I dissolved them in some water, and I made several solutions out of that with known amounts of vitamin C. It says right here how much each one has. 0.1 milligrams, 0.25 milligrams, 0.5 milligrams, 0.75 milligrams, or 1 milligram. 1 milligram is 1,000th of a gram. So it's a very, very small amount of vitamin C. And so what I'll do is I'll titrate each one of these to find out how many drops of the titrant it takes to change the color, and then we'll use those data to make the standard curve, the graph that works like a ruler. It shows you for any particular amount of vitamin C how much of the titrant it takes to change its color. That way, if you know how much titrant it takes to change the color of an unknown solution, you can find out how much vitamin C it contained. Let's look at how the titration procedure works. I'm going to titrate the first sample for the standard curve. This is the one that contains 0.10 milligrams of vitamin C. Into the sample, what I put was a half a milliliter of this starch solution. That's going to be my indicator. Just like in our titration experiments when we used phenolphthalein, the substance that turns pink at the end point of the experiment, I'm using the starch. It's going to turn dark blue. And my titrant, I'm going to use iodine. I made an iodine solution using an iodine tincture that I got at Walgreens. It's sold in the antiseptic section. So what I'm going to do is I'm going to add this titrant 1 drop at a time and look for a permanent color change. So each drop I add, when I put in that drop, the iodine is going to react with some of the vitamin C that's in the sample and use it up. So the amount of vitamin C is decreasing over each addition. That's 2 drops and 3 drops, and I have to keep track of how many it takes. 4 drops, 5 drops. The more vitamin C there is in here, the more drops it should take to reach the end point. 6, 1 drop, 6. Get some more here. 7, 8. It's starting to change and stay changed. 9. Okay, so that's the end point that we're looking for. It took 9 drops to reach the end point for a mixture that contains 0.1 milligrams of vitamin C. So that's 1/10 of a milligram, a very, very tiny amount. And then what I'll do is I'll do the same thing for each of the other samples that have more and more of the vitamin C. It should take more and more drops to reach the end point, and then use that data to plot the standard curve, so that if we know how many drops of iodine it takes to reach the end point, you can tell how many milligrams of vitamin C were in the sample. Let's take a look at the results of the standard curve analysis. So I asked you to prepare some data tables. This is the data table that you need for this part of the experiment, the one where you're going to keep track of how much vitamin C was in the sample and how many drops of iodine it took to reach the end point. So let me show you for each one of those samples what happened. So the first one I showed you, it was 0.1 milligrams of vitamin C, and that one took 9 drops to reach the end point. And then the next one, 0.25 milligrams. This one took more drops. It took 20 drops to reach the end point. And then the next one, 0.5, it took 48 drops to reach the end point. And 0.75 milligrams took 64 drops. And the 1 milligram sample took 93 drops. So you're probably thinking, man, I'm glad I didn't have to count all those drops. And yes, you are. I did the work for you. So now what you need to do is make sure that you have those data recorded in a data table like this, so that you can use them to plot the standard curve graph. For this part of the experiment, I asked you to prepare a graph that you're going to use to plot the standard curve data. So you should already have something that looks like this. It should have the axes labeled. It should have 10 marks going across the x-axis, 10 marks going up the y-axis, equally spaced. And I said I would tell you how to scale each axis by giving you the number that goes here at the end. So the highest amount of vitamin C that was in the standard samples was 1.00 milligrams of vitamin C. So you can label this one right here 1.00, and then you'll need to label the other ones 10 equal divisions of 1.00. And then going up this way, the highest number that you'll need to plot is, 93 drops. So if you scale this axis so that this one right here is 100, and then you go by tens, 10, 20, 30, 40, and so on up to 100, then you should be able to plot those data. So each cup, for the 0.1 milligram cup, you'll have wherever 0.1 milligrams is on here, and then it says 9 drops. So you go up 9 drops and make a point where that would be how many drops, how many milligrams. And then you'll have 5 points for each of those 5 cups. And also include the origin. If there's 0 vitamin C in the sample, it will take 0 drops to reach the end point for that titration. And then what you'll do is you use a straight edge, anything that's straight. You can use the edge of a book or a ruler or whatever you've got, and draw the line that fits best to those points. It doesn't have to touch all the points. It should kind of go right between all the points, like you're shooting an arrow through the trees in the forest, and it doesn't hit any of them. It might hit them all if they're right on the line, but you want to get one line that goes as close to all the points as you can get it, that goes through the origin. You'll need this graph so that when I show you how many drops of titrant it takes to titrate the samples of apple juice, you can find out where that meets on the plotted line and find out how much vitamin C was in each one of those samples.